Hi, I'm Rajat. So today we are going to talk about how C language was developed. What was the motivation behind developing this programming language? And why we always say that C is the mother language of all the programming languages. So we will touch upon the history of C and also see C from the historical perspective as well. So in order to understand where the journey of C was started, we all need to go at the time when the idea was somewhere in the University of Massachusetts. So I'm talking about the University of MIT. So it was the early year of 1960 when this idea from MIT originated. So back then in 1960s, back then in 1960s, we all know that computers were very bulky. They were not very small machines that you can carry anywhere and these are very sophisticated and efficient. No, they were not like that. Now, the computer back then were the sort of computers where a person can work and then, with a lot of efforts, we are performing a particular task and then we are getting the output, so on and so forth. Now, MIT people think that why not to create some sort of a system on which not only one person can work, but the computing resources must be shared among dozens of people. Can we do that? So the time sharing operating system idea was very revolutionary at that time. Now, in order to make it possible, people in MIT, they created an initiative known as MAC. Let's talk about a bit more about this MAC. What was this initiative? So this MAC was Project on Mathematics and Computation. So as it was launched by MIT, the main goal of this project was to explore time-sharing systems, artificial intelligence, human-computer interaction. So basically, these are the three aspects that MIT people wanted to research, a bit more and make it a reality. Now, in order to do that, we need some sort of a project that we can build. So that time, those people started thinking about an operating system that is, secure, scalable, multi-user. And this is the point when Multics originated. Multiplex Information and Computing Service stands for Multics. Now, they have this idea to set up to create the Multics operating system. Now they started working on it, and MIT cannot work just alone. So they created a joint venture. So basically, three entities came together: MIT, Bell Labs, AT&T Bell Labs, and then General Electric. Now these three parties came together, started working on this Multics revolutionary idea, and they were working on it. Now, soon they met with a problem. So the Multics was like very complex system because the ideas, the concepts that Multics was having that time were actually very revolutionary. Those were not very common thing that you can implement when the technology is there, you can do it. No, the technology was not there, the resources were not enough, so that was the problem. Now when Multics started, soon it was like the whole idea was falling apart. They get to know that the software is too complex to build and the progress is also going on very slowly, and also they need more capital. So the project was expensive, and that is why, out of frustration, MIT just withdrew from this particular ambition. Now, that was a setback. Now, the thing is that whether Multics is going on or not, still the revolutionary ideas that Multics came up with really make people passionate about how about a system where multiple peoples are sharing the resources, working simultaneously on a same system. This idea was the same thing that our three computer scientists were very fascinated about: Ken Thompson, Dennis Ritchie, and J.F. Osana. Now, they refused to abandon the vision of Multics and they started building their own system. So in 1969, Ken Thompson has his machine, PDP-7. It was a mini computer with just 8 KB of memory. So he began crafting a new operating system. So he started working on a new operating system. Later, he named it as Unix. And in 1970 to 1971, they wrote this whole operating system in assembly language. Now, however, this approach came with a critical limitation, this assembly language writing thing. So the problem was that the system was completely tied to the hardware architecture of PDP-7 system. Now, the Unix is not portable anymore. You cannot just take Unix from, PDP-7 architecture and just install it somewhere else. So that was not there. Now, the other thing was obviously this leads to the portability problem. So obviously, when Bell Labs started using Unix and it grew, its popularity grew. So it was very hard to make it portable. Now, what to do? So Ken Thompson created a new programming language inspired from BCPL. It was simplified, highly efficient, and also it was simplified language, high-level language, and designed to make Unix more flexible and maintainable. But then again, the language has its own limitations. For example, it was lacking in the uh, sort of data types. So there were no data type. Basically, only a single data type was there known as machine word data type. So anything, whether it is integer, pointer, anything. So it just considered everything as machine word. So that was a problem because uh, this oversimplification made certain programming tasks awkward and inefficient. And also, the B language was lacking in complex data structures. So structures were not there, arrays were not there. These sort of problems are there. Memory management challenges were also coming. So that was a limitation of B language. Now, how can we resolve it? So Ken Thompson and Dennis Ritchie, they came along. Dennis Ritchie has its idea that, okay, let's just create a new language, which is expressive and can solve this portability issue. Let's fix it. So they started creating C language. So Dennis Ritchie is the father of C language. He created it. And the main thing is that C language, being a high level language, letting the users to write in English sort of language, still you have the full control over the hardware. For example, you can control the registers, you can access the memory, you can do the bit manipulation and a lot of low level things that were not possible before. Assembly language could do it, but then it was inefficient. Now, the C language was closer to the hardware, and also it was very rich in the features, like, for example, the data types were there: integers, floating point numbers, characters, arrays, structures. So it was rich in that. And also the portability problem was resolved. So C was designed from the ground up to be portable across different computer architectures. So the language specification carefully abstracted hardware details while providing enough low-level access to write system software. So the idea of C was that you can write once and compile anywhere. So this was the philosophy that C came with, and it was really very popular. So all you have to do is just create your own program, compile it on your machine, and the compiler will convert your code into the machine specific instructions that your hardware can understand. And now there is no problem. Whatever system you are using, you can just have a compiler. C compiler on it. You can just compile your program and it will create the machine instructions that your architecture can understand, and definitely your program will run. So the portability problem was solved. Now there was a philosophy. So C was not just a language; it was a philosophy. Write once, run anywhere. Be efficient, but never lose clarity. Let the programmer control the machine. So this was the main idea that C was developed with. And this was all because B was efficient. And B was there because we wanted to create an operating system. So this all started by having that vision of time sharing operating system. Now, so when C was mature enough, Ken Thompson and Dennis Ritchie decided, let's just rewrite the Unix in C language now. So the team systematically converted 1,000 lines of PDP-7 assembly code into portable C. So this was not just merely a translation that you are just translating the code from assembly to C language. No, it was a complete reimagining of how system software could be written. Each module was carefully crafted to take advantage of C's expressiveness while maintaining the efficiency of Unix that Unix demanded, right? So portability test happened, then performance validation happened. So everything was working very smoothly. Unix was running so good that the Unix version of C was really commendable. So it was working really good. And then the portability issue was also resolved. So it was a commercial success overnight. So whatever was taking, months of efforts, making the Unix operating system portable to some other system, you are just converting, the assembly code and changing it according to the architecture where the Unix is going to be installed. So it takes a lot of months to do that, and now your C is just very efficient. It can handle most of the critical portions, most of the problems, architectural differences. It can handle automatically. So that was very good thing. Now, when the Unix was a success, this news everybody was shocked that how a language can do that and sort of thing. So C was very popular back then because it has done something that people could have just imagined. So that was the only reason that C was so popular, and also the concepts that C introduced, for example, the pointers, for example, the bit manipulation concept of data types. So it was really efficient, and having it really shows that how a language should be. So then C++ came, Java came, C Sharp, Python. Everybody adapted their syntax and semantics from the C language itself. That is why C is considered as the mother of all languages. Now that was the whole journey that she had, traveled to reach us in 2025. So this was the whole idea why she was developed. So you are now a part of this. Maybe you are just a beginner who is very passionate about programming, want to write some software, create games, or whatever your vision is. I will just say that if you are learning C, it's your chance to understand the machine, the hardware, how the hardware is interacting with the software, and the vice versa. So this is a perfect time when you understand how this communication is happening. And C will definitely help you with that. If you understand each and every tool that C offers you, for example, pointers, for example, the conditional constructs, if else, ladder, the switch case is there, loops are there, all sort of tools that you are going to learn in this particular language going to help you a lot. Maybe whatever field you choose in future, maybe AI, ML, whatever, C is going to be your perfect partner. So thank you so much for joining me in this video. And if you have any doubts, please comment down. I will help you. I will read your comments and try to help you out. So we will meet in the next lecture. Thank you so much.